I, at first, I would like to thank you very much, the esteemed board of the yoga, or Sky Yoga, for this invitation. And I have to honestly to say that I'm really, in the last 2 days, I only slept 6 hours, but all the hours I spent with conscious have been flashing me totally. I would like also to provide some words to the students. And as my colleagues knows from the Trans-European Stem Cell Therapy Society, I'm also still teaching. And I have to say that I get my inspiration from my students. And I have to say that I adore my students in the way that I fully respect them. It could be a talented kid with IQ 135 plus with 9 years, or it could be a doctor which I discuss scientific problems. I don't make any differences. And so I have really to give to thank the students very much for all their interest and their motivation. And I think the responsibility of the teacher is not to bring over knowledge. The knowledge the students can get from YouTube videos and from the social networks. I think as a teacher, my job is really to make sure that they're getting the right connections. Okay, thank you. So that they get really the right connections and that they have to answer questions themselves. It's not my job to answer questions, it's a job to take the knowledge and to create perhaps new knowledge and to find solutions. Okay, so then I will straight go into the area I will talk today. Quite challenging on one hand, on the other hand. Okay. So this is just a summarize from where I come. The Trans-European Stem Cell Therapy Society was founded nearly 15 years ago. The aim was to perform funding proposals for the European Commission, and the base was to combine different disciplines like clinical medicine, as well basic research, ethics, social science. And so over the years, we developed to a think tank. So think tank means we have excellent people in our consortium, and we exchange. We are interested to drive projects such as clinical studies, especially based on stem cells and stem cell technology. Okay. Okay. Now I would like to come again. Now I really jump into into my subject. Quantum physics and spirituality. So on the first look, it seems to be that these are both worlds, and there are expectations from the spiritualists, and there are opinions of the scientists. And I think what I try to do in the next 20 minutes, I try really to see what is common sense, what can be connected, is there a connection? So I will pose questions and you have to answer it yourself. Oh, okay, I have a clear opinion, but I think I leave it then on you. So this is a bit unusual. This is a photo from a movie named Everything, Everywhere, Everything All at Once. And this is a movie which was surprisingly extremely successful because the subject of this movie was quantum physics and spirituality. And the question, is there something which we can do differently or better? So simply asking basic questions of the life. And the reason I start with this, and which is so remarkable, is that also young people which running into the movie are interested in basic questions. Is it possible that there is a parallel universe? Is it possible if I do something different, I can change my future? Or I follow a fixed phase? It's a bit distracting, perhaps. So what's crazy about is that this woman is really the same time in totally different universes. And in every kind of universe, she's really able to show that she has a totally different kind of potential to solve problems of her life. Okay. So I just leave it, we keep it just a memory. Now, I had really also to ask for myself, what's spirituality? And so I came to the point that spirituality is asking questions for the meaning. Oh, you don't see it. The purpose, connection, experiences, and physics. Subject is on matter, on energy, on space and time. So one question could be, so that means that physics is not asking, is there a meaning? Could be there a God? Could be there a creator? So physics as a pure science is measuring and is comparing the measures, data, especially in the area of physics, with experiments. The question is there any room to ask why? So to come here to a conclusion, I just it's not strong enough. So I just going into the history of physics, and I hope it will be not too dry. So I just you see phases, and they follow a timeline. And I have to say that this is the way physics, or the entry of physics in the educational curriculum is taught. So it starts by the Greeks with Archimedes and with Democritus. So they created the concept of the atom, and they believe also that atoms are an entity which is like spheric and which cannot be separated, and that everything which is matter consists out of atoms. Then Archimedes, he produced really milestones in science because he calculated P, the perimeter number, which is infinitesimal, so which has no end in numbers. Then the next big step is Galileo Galilei. So in Middle Age, the Europeans have forgotten some knowledge of the Greeks, so the church believed that the center is the earth and the sun is circulating around it, and Galileo Galilei did find the proof that's untrue, and it caused them a lot of problems. Then the next guy is Tycho Brahe. So Tycho Brahe did work extremely scientifically in the same way like Galileo Galilei. He observed the planets and he put down numbers and digits and figures about the running time of planets and the positions. And this data have been used by Kepler to exactly calculate at first the run of the Earth around the Sun, and he did find out that this run around the Sun is elliptic. It's not round, it's really elliptic. Because I have no writer, I cannot write it here, but it's not a problem. That means he used really clearly scientific methodology. He used observations of his colleagues, he used the data he got, calculated exactly, but he didn't know why the Earth is performing elliptic and not like a circle. So then, okay. So then we come to this person here. This is Newton. Newton was a very interesting person because he was not very much beloved by his colleagues. One point. Yes, correctly, Thomas. And he got very rich with science, is another point. No, it's not mine. So, but by the way, he did find out that gravity is a force, and he could formulate it in a mathematical way. So you know the three laws of Newton, and this is the base for modern physics. Really, the baseline for it, because his knowledge was used by all physics which came after him. Now we are in the modern times, more or less. So 1928, Werner Heisenberg published his theorems about uncertainty, which can be very simply explained. It's for him, with his equation, it was not possible to, when you look onto, okay, so this is an atom, it's friendly today. What you have here the electrons, you have neutrons, protons, and based on his equation, it was not possible to estimate the same time, location, and the time of this subatomic particle. And this was a big problem in this time because there's, I'm going back, because here is Albert, so Albert Einstein. Perhaps you know that he's very, very connected to Switzerland. He performed his school in a place near Bern in Aarau. And then later off as a scientist, he didn't got directly a job in university. So he worked as an, I would say like an official at the patent office in Bern. So, and in this time, as a really ordinary worker or ordinary person in a patent office, not patent office, it's an official office from the government, he was able to develop the relativity theory and the general one and the special relativity theory. And this was purely based on Newton's physics. And Newton's physics was able to explain time and space in the way that time and space is relative. That means, for example, that accelerated watches running with delay, and that a mass which is strongly accelerated will be condensed. Special relativity was theoretically showing what is gravity, and he could show that gravity is a force which is able to bend the light and the space. So this is quite simple. The mathematics behind is quite complicated. A lot of his mathematics was done by his wife, by the way. So that means gravity, space, time shifts. This could be extremely well explained. And what is really the outstanding work, or what is outstanding on the work of Albert Einstein is that he theoretically calculated that gravity will pull light and will bend light. And it was then proved in an experiment years later. And he didn't receive the Nobel Prize for Relativity theories, these two theories. He received it for the photoelectric effect. Photoelectric effect is very simple. That means that light has energy and is able, oh, that's the sun, so it's emitting photons, the photons carrying energy, and this energy is able then to excite electrons. And this was finally the work he was granted with the Nobel Prize. I left out the conversion of energy into mass and vice versa, because this is really, I think, trivial. Everyone knows this. But what is remarkable here is really that at that time, the classical physics was really quite in order, because it was everything fitted together. Theoretical mathematics with the experiment. And then came this guy, this German guy, Schrödinger, and told the world, oh, sorry, there could be a small problem. Because when you go much deeper on the subatomic level, then you have no shells, as developed, this model developed by Niels Bohr. By the way, when Niels Bohr got his Nobel Prize, he got also a beer pipeline by the local brewery to his home, okay? Niels Bohr model, the typical Bohr model, are the shells. You have on each shell, first you start with 2, and then maximum number of electrons is 8 electrons. So I think this is something everyone from you, I hope, got in his science lectures when he was a kid, more or less. At least in mine. Okay. So the world was in order, but not for the German guy. So for him, there was not a predictable location and time. By the way, for Albert Einstein, he had a very simple explanation for time. For him, time was just what the clock shows. So there's no magic about time for him. To explain why accelerated watches are getting slower, this I can explain later in a very simple experiment. That's not so difficult to understand. Okay, so the world was in order, but for Schrödinger, there's not a really fixed way on which the electron is moving. For him, there is a cloud. And finally, the electron is either here, everywhere. And the more exact you like to measure it, the more problems you come, because the more exact you try to estimate the location, the more the time where it is, or at which time it is in this location. It's getting more unprecise. And this is something the Newton-based physicists or physics hated. They had a problem with it. You have clear calculation, experiment, it fits, okay. But here, you have a probability, stochastic process or probability. And this is something which made Einstein uncertain. So, okay. And based on this, paradoxon, that it was not possible really or to get only approximations of the data. This provoked problems. Because there was one generation at that time which really started off to get much more into the quantum physics and to understand more in this way. And Albert was quite stubborn. Okay. Then I would introduce Satendra, I hope the pronunciation is right, Satendra Nath Bose. This is an Indian mathematician, and at the time Heisenberg published his equations on uncertainty, or theory on uncertainty, he published a paper, and it was totally unscientific because it didn't use any reference to other colleagues which did performed work in this area. And this publication came to Albert Einstein, and Albert Einstein looked over it and came to the conclusion, wow, that's cool. That's interesting. So Albert Einstein was able to recognize the significance of his work. It was then also translated into German. And his work led to the development of the so-called Bose statistics. I don't want to get too much into this. Finally, one of the very, very important subatomic particles, the boson, is named after Bose. Okay, that's a fantastic contribution from India. What's remarkable here is that he didn't follow the rules. He had the idea, he made it, published, and it was good quality, and it was recognized. Could it be possible with nature or science? Only if you have good friends. Okay. I hope it's not too boring. It's history. So I just refer to the bosons because for the Newton mechanics, gravity was described very well by Albert Einstein, but gravity was not, or it was not able to describe the cause of the gravity with Newton's physics. So Peter Higgs proposed then, much later, the so-called Higgs field. So we're talking about a field or a cloud. And we talk about statistics and probability. So, and what's remarkable is that the nature of gravitation, and there was this Higgs particle was mathematically and theoretically discussed, which would transfer the gravity to neutrons and protons. Because neutrons and protons They making the mass, and neutrons and protons making hydrogen with one proton. They making helium with two protons, and so on. So the chemical element is really defined by its mass. But it was not possible, even for Albert Einstein, really to answer the question, what is the cause? What kind, or what is the mechanism and the principle behind? So, and what is really cool, the so-called Higgs boson, which was theoretically postulated, was detected in 2012 at the Large Hadron Collider in Geneva, in Switzerland. So, the European Union financed this project together with the Swiss government, nearly with between 1 and 2 billion euro. And now this kind of data they produced are really breathtaking. And that was a really good justification to spend so much money for such a project. So finally, based on these experiments, finally it was possible to explain the nature of gravitation. So Einstein described it, but he was not able to explain it. Very simple. Okay. Same problem like Newton. This is Dirac, a British guy. He got his Nobel Prize in a very strange year, 1933. He performed a very strong contribution to the quantum physics with the theory of quantum electrodynamics. And this quantum electrodynamics, for example, is related to the photo effect discovered by Albert Einstein, and without this work, we would not have solar energy, because solar panels are based on this technology, as an example. So, before I made a mistake, I gave the wrong name. So this is Werner Heisenberg. Werner Heisenberg was also the father of the German atomic bomb, which never came into production or into the experimental state. Experimental, yes, but it didn't work because he miscalculated the critical mass. It's speculated he did it because he was not good enough in mathematics, which I doubt. Okay, but we leave it here. Albert, okay. So if you have the chance to come to Bern, there's the Albert Einstein house, where his home where he lived as a museum, as well. There's a durable exhibition I like also to visit with my students, dedicated to his work. Wow, cool. Okay. So, I'm sorry, we are not in spirituality yet, but I promise it will come. Now we're going a bit more in philosophy. That's a famous Schrödinger cat. And I think everyone knows it. And what you see, perhaps it works here. Oh, yes. You see waves. So, dead, undead, dead, undead, dead, undead. So the cat is dead and alive at the same time. That's this paradoxon. And Schrödinger's idea was just to tell the world, okay, there is a discrepancy between the quantum world and the real world. because I'm not an electron. Even I would like to be. So that means the behavior on the atomic level, it's much different to the behavior in real world. But times are changing, and now we're talking about quantum computing. So it looks like the two worlds coming a bit nearer, or at least there's an impact of quantum physics on our daily living. Okay? Yeah, okay, so Thomas, you told me to change it. Yes, I was too sleepy. Role of quantum states in neural functions such as conscious. So what does it mean? Quantum brain hypothesis. Now we're jumping into biology and into a connection between the brain and quantum physics. Okay, and this is really complicated. I don't understand it really in depth, because when I had many brains in my hand, many human brains, when you look into the structure, the macroscopic structure of a brain, it's clear you have structure and function in combination. You have neurological, or you have neurochemical processes. So the brain is producing electricity. It's enough for a 5-watt bulb. So this bulb is enlightened by some people more, by other people less. That's part of our nature. Okay. So the brain, so we have, it's very simple, a neuron. This is maximum simplified, you know. So the neuron has this so-called axons, and they are like electric cables. So electrochemical signals are based on this kind of axonic connections, and so information within the brain is integrative, worked out, and the potential of this brain to integrate and to convert information into movement, into sensory actions, and so on, it's incredibly high. And the idea behind the quantum brain hypothesis is that the structure we see is not enough to explain why information in the human brain can be integrated so rapidly. And the power of the brain, the computational power of the brain is extremely high, and much higher than you would expect from the macroscopic structures and from the architecture. And so now it's discussed that in the human brain, information is not only conducted by neurons, that also information is transported or transferred by quantum processes. So then you look on waves and clouds again within the brain. And so that's the background of this hypothesis. The problem is really to perform a methodology which really can prove this kind of hypothesis or hypothesis for the moment. Okay. So, big question mark. Okay. Now I come to consciousness. Consciousness is a principle we discussed yesterday in the small round. It's very much important for spirituality. Yes, I talked too long, I'm sorry. I'm boring, you know. So, simply, is classical physics sufficient to explain neural function, which is based on neural networks and electrochemical processes? Okay. I have to go forward. So, now we know no. So that's my opinion. You have to find also your opinion. You can read. You can check out on Google what you find. Perhaps you find different solutions. As a neurologist, you have perhaps different opinions. And now I come to the conclusion here. So this is a very strong symbol which stands for spirituality. We have the atomic bomb, which is a symbol for quantum physics and science. Okay, I know, I'm too late. And this is J. Robert Oppenheimer, who is the father of the atomic bomb. Now you ask, what has everything to do with each other? Everything is connected here. Because finally, Oppenheimer developed with his colleagues, the best brains of his time, a weapon, a terrible weapon, which is based on state-of-the-art physics at its time. And spirituality would ask the question, why is that necessary? How many people have been killed with this bomb? So Oppenheimer, when the bomb was used, not in Germany, which was proposed for, then he started to think over the process. And as you know, Oppenheimer was also able to read Sanskrit. I think he was very deep also, from my point of view, also, even if it's not in his conscious, but here is some spirituality which plays in this basic question. Why? Why does it happen? Is spirituality, is from my point of view, now I give my personal idea, it's absolutely necessary for a scientist also to ethically check out the impact of the work he's performing. And with these words, I would like to finish. I'm sorry I overtook the time, but I hope, anyhow, you had some fun with it. So, thank you very much.